screen over here. Okay. So from here, in order to create the project, what we want to do first is we just want to go to new project. So click on this. And then you want to make sure that your editor version is 2020.3.25. If you have 3.26, that will work as well. But if you have 3.25, just use that. And then from there, what you want to do is you want to make sure you're on all templates and you want to click on 2D because we're just going to be making a 2D game today. From there, just specify a project name. So you can name the project just whatever you want. I'll just name it DSC Unity Workshop. Oh, sorry, that's already new. So I'm gonna just call it a 2. Okay, so then from here, I'll just click on create project and that'll create the project in the background. And this will take a couple minutes. So while we're waiting for that, let me get back into the presentation. Okay. Does anyone need me to go over that again, or is everyone like good? Okay. Let me go back to the slideshow then. All right, so I'll pass it over to Bilal to talk about why we're going to be using Unity and explain what exactly is Unity.
Yeah, thank you for that. So to start off with, the first question that some of you might be asking is, what is Unity? And to answer that, you can understand what Unity is by knowing that Unity is a tool that is used to make games, or in more specific terms, a game engine. So Unity can be used to build games for almost any platform and making animation for films. And lastly, also to facilitate any kind of simulation with AR or VR, which I have some personal experience with. Being my first co-op was at a startup that made training tools for CPR, And if any of you guys have questions at the end of the presentation, you can ask me and I can link you my LinkedIn or something and we can have a chat about that. So, and another way to understand what Unity is by seeing how it connects different visual parts of a game to make a complete game with its code editor and related tools. So moving on. So some of you might be wondering why someone would want to use Unity. One of the simplest answers is that it's widely used in the gaming industry. With the games listed here being Hollow Knight, Cuphead, Fall Guys, and many more that you might recognize, it is very well used in the industry. Another reason is that it is completely free to learn and work with, and only in some commercial use cases you get charged by Unity for using their tools, which I'm assuming most of you guys wouldn't fall under, at least initially. So also it uses a pretty popular language called C#, which is syntactically and structurally very similar to Java, if any of you guys have experience with that. And lastly, Unity has a built-in asset store that allows users to get any assets that they want to get into their project very seamlessly, and as a result, speeding up the development process greatly. So moving on. The main goal of this workshop is to build a 2D platformer, right? So let's get on to let's give a small introduction to what you guys will be working towards. The game will be a basic platformer with the character that has the ability to move with the 2D plane left and right, along with being able to jump with all of this with an introduction on how to make platforms with basic player animations for character and idle movement. So it doesn't look like you're looking at a screenshot while you're playing the game. And that GIF can also illustrate some of the gameplay right there. So moving on from there, let's start talking. So let's start off with one of the key concepts to understand working and developing in Unity. So one of the key concepts is to understand what working with Unity is the physics in the Unity game engine. There's a game object's position given by X and Y coordinates, similar to a Cartesian plane if you have experience with that in math or physics class. But rather than being relative to your paper, it's relative to your screen. So it's directly related to wherever it is on your screen. Then there's a game object speed, which is a directionless measurement of how fast something's going. So it can be something like 20 meters per second, but it's just that, no direction associated with it. But if you want a direction associated with it, you can use velocity. Velocity, being a very similar measurement, is speed with a direction, as I just said. Then there's gravity, which can be controlled in the game and does not have to be the standard 9.8 meters per second squared, like what you would have experienced within physics class. It can be anything, and we can control that in the game or in the Unity environment, rather. Lastly, an important tool that we will not be using is time.deltatime, which helps in setting speed, and as such, it has the time between each frame, so it can be used to coordinate the time and speed. And if you want to learn more about that, you can learn more about it on your own time. But now I will hand it off to Zahid for more concepts. Yeah, you're muted.
Yeah, sorry about that.
All good.
So thank you, Bilal. So right now we're going to be talking about some important 2D game development concepts. The first of which is a sprite. So what is a sprite? A sprite is just an image that represents an object in the game. So over here are some examples of just some static images that we'll be using today. So over here is like the sprite for the idle animation for the player. Over here is like the running sprite for the player. And then over here is a tile sprite, which is a platform sprite, which we'll be using for the platforms. But the thing is that the sprites themselves, since they're just static images, they don't move, right? So that's where the sprite sheet comes in. The sprite sheet allows you to combine a bunch of sprites into one big image and allows you to select from the different images and use that to form an animation, which I'll show you in the next slide. But over here, you can see in the sprite sheet, you can see a bunch of different images of the player. So you can see that these 8 sprites over here represent the idle or the idle sprites for the player. You can see from here to here, the running sprites for the player. There's some attacking sprites, and there's a lot more. So it's very convenient to have all these sprites in one big sprite sheet. So to go over what an animation is just a series of sprites that run frame by frame. So we can take these sprites over here, these idle sprites together, and we can run them frame by frame in order to form this animation over here. And that's how animation in 2D works if you're using like images. If you're using models, it's a completely different process, but since we're using images, this is how animations work in 2D. Okay, so let's go over some very important Unity concepts in general. So one is the scenes, which are essentially just the level of the game. And just like any video game, you can have multiple different levels. But for now, we're only going to be working with just the one. So we're not going to be creating any new scenes or anything. We're only going to be working with one. Another very important concept is the game object. Every object in Unity is represented by the game object. So this includes stuff like the player, the enemies, the tile maps, even the camera, etc. So it includes pretty much everything in the game. So everything in the game is pretty much represented by a game object. The next thing to go over is scripts. So scripts is simply just C# code that can be assigned to different game objects. And because Unity doesn't have its own built-in code editor, we have to use Visual Studio to edit them. And Visual Studio is actually a very good code editor because it has some really cool autocomplete features, which will be very useful when we start coding for this workshop. Okay, so some other very important concepts in Unity. We're going to be talking about some of the functions that are used. The first function is the start function. This is called at the very start of the script, but it's only ever called once. So this will be very useful for getting the components of the game object. I know you don't understand what I mean right now, but just keep that in mind because we'll be using the start function for that purpose in the code later on, and I'll explain that in more detail. The next function is the update function. This function is called at every frame. And because it's called at every frame, the majority of code goes in here, since, as we all know, games run by every frame, right? Because you use terminology like game is running at like 60 frames per second, 50 frames per second, whatever. Right? But what's important to note is that the time between each update call isn't going to be consistent, because as we all know, games can experience some frame rate drops. So for example, if the frame rate drops from 60 frames per second to like 10 frames per second, then the time between each frame will be longer, right? So that's a very important thing to note. The fixed update function is something that's called at a fixed time interval, which is specified to 0.02 seconds by default in Unity. So that simply just means this function is called every 0.02 seconds. So it doesn't depend on the frame rate at all. It's just called every 0.02 seconds. And the physics calculations and stuff typically goes in this function. Why is that? Well, first I'll show you guys this diagram of the start and update function and how everything works. So when the script is created, and this typically happens at the same time the game object is created, the start function runs first, right? And this only runs once. After the start function runs, then both the update and fixed updates are running. And then, as I mentioned before, the update function gets called at every frame, and the fixed update function gets called every 0.02 seconds. So going back to my earlier question, why do we have to put the physics calculations in the fixed update function instead of the update function? Well, let's look at this diagram over here. Let's assume for a moment that we put the physics calculations in the update function. And let's also assume that the player is moving at 20 meters per second. Their velocity is 20 meters per second. So at the first frame, let's say the player is just standing over here, okay, minding his own business. Let's say in the second frame, it takes 0.01 seconds to get from the first frame to the second frame. So if you do the math, 0.01 seconds times 20 meters per second, that means the player moves 0.2 meters from the first frame to the second frame, okay? And this is actually a really good time because this means the game is running at like 100 frames per second. Now let's assume the frame rate drops like significantly, right? It goes from 100 frames per second to like 10 frames per second. And so then we assume that the time between the frames, second frame and third frame will be like 0.1 seconds, okay? So instead of moving 0.2 meters like they did here, because the time between the frames increased, the player's movement also increased. He moves 2 meters instead of the 0.2 meters over here, because now the time between the frames is 0.1 seconds instead of the 0.01 seconds. So because of this, because the player moves from here to here, like just instantly into 2 meters, he can actually miss collisions that are in front of him. So this object over here, he just misses because he just teleports from here to here because he just moves the 2 meters, right? So because of this, the player can miss a collision, and this is why fixed update is going to be so useful, because fixed update is called at a very fixed time interval. It's called every 0.02 seconds. That means the player will consistently move at a small amount of distance every time. So we can see here that from the first fixed update call to the second fixed update call, he moves 0.4 meters. From here to here, he also moves 0.4 meters. And because of this, he will properly collide with the object. So that's why fixed update is so important, because it just makes the physics calculations a lot more consistent. Good. Is there any like questions on this, or are you all good?
Noor Ibrahim seems to have a question. Yep.
Oh, no one has a question?
Noor Ibrahim has a question. You
Oh, he
can unmute.
does?
You can unmute yourself if you want.
Okay. So first of all, it's a very nice opportunity to be here. So I was just about to ask. So in multiplayer games, like the ones we're used to play, 3D multiplayer games online. So do they only like use fixed updates? Because I don't know, because everything is about physics there.
For multiplayer games, yeah, I'm sure they still would use fixed update because you want the calculations to be consistent, right? And every player will have a different frame rate on the computer, right? Like for example, if you're playing Minecraft, some people will have like 100 frames per second running. Like some people will be able to play it at 100 frames per second, and some other people might be able to play it at like 50 frames per second, right? So if we use the first method, then the players will move at like different will move like different amount of like distances. If we use the fixed update, then every player will move like at a fixed distance every time. So I'm sure that multiplayer games would use the fixed update function. Does that make sense? Or
yeah, makes sense. Thank you.
Yep, no problem. Okay. All right, I'll move on then. So now let's walk through the Unity menu. The first window we're going to be going over is the hierarchy. The hierarchy lets you view all the game objects in a specific scene. And in order to actually create a game object, you just right click in the hierarchy, or you could click the plus button over here. And if you're familiar with object-oriented programming, and don't worry, you don't need to know it for this workshop, but if you are, you can specify parent-child relationships between the game objects. And an example of that over here is that the grid is a parent of the tile map, and you can just specify the relationships by dragging the objects underneath each other. So the next thing is a scene view. This allows you to specify where to place game objects in the scene. In this view, you can also resize and rotate the various game objects. The other very important view is the game view, which actually allows you to test and play the game. In this view, you can play, pause, and stop the game through this view. So you can see over here, there's the play button, there's a pause button, and you can stop the game as well. The other window is the inspector window, which is something that lets you view, modify, and add components to a game object. And you can modify components by either like typing in the values over here, dragging and dropping, or selecting values depending on what they are. And you can add components by clicking add component. So a question you might be asking is, okay, like what is a component? So some examples of components include the physics of the game object, which is just called the rigid body 2D. Another example is the collider 2D, which gives your game object the ability to collide with other game objects. So we can just add these by clicking on add component, which we will do later in the workshop. So the other important thing is the project, which is a window that allows you to view and organize all the different assets that you used in the project. So this can include the sprites, animations, the tiles, music. There's a lot of different assets that you'll be using in the game. And you want to keep everything organized, right? So you want to try to put things in folders like I did here. And the last important window is the console, which allows you to view printed output and any errors from the C# script. In order to print to the console, you use debug.log. So for example, if I say debug.log hello, I can print out hello in the console. A question you might be asking is, okay, why is it printing out hello like so many times? Because if I put this debug.log hello in the update function, and as I mentioned earlier, the update function runs every frame. So it's printing out hello every frame, and this will be very useful, printing out the values every frame. because we want to know the game state every frame, because that's going to be important. Okay, so now let's get to actually creating the 2D platformer. So before we do that, I just want you all to download some assets over here. So let me open this link, because these assets contain some very important things like the sprites we're going to use. They're also going to contain the animations and a script that's going to be used to actually play the animations. So I'll just send it in the chat, or, oh, okay, no, never mind. Omar got it. Thank you, Omar. Appreciate it. Okay, so what we want to do from here is to just download all the assets. So we're gonna click on this. We're gonna shift click. Make sure you get the .meta files. What a .meta file is literally just like memory of things that I did to these files. Like for example, it remembers that I like split the sprite sheet into multiple sprites, like for example, or I modified some things in the script as well. So those are very important to download. So just download all these. And then from here, just open the folder. And then click on extract. Just extract it wherever you feel is like easiest. So I'm just going to extract it here. Because what we're going to do is we're going to be dragging and dropping these files in Unity. That's how you import assets. It's like as easy as that, which is really nice. So let me open up Unity over here, because it finally opened up. And let me drag these folders and the meta files into the assets. So you just select all of them and drag and drop it to the assets over here. Okay. And it should, yeah, there you go. Now all the folders are over here, and we could use those in the project. Okay. Does anyone need me to go over that again, or are you all did you all get the assets imported properly?
Can you go over that like again real quick the way you did? I didn't quite see it because I was trying to update my Unity.
Oh yeah, sure. So you got to this step, right? Like you downloaded the assets and you extracted.
Yep, all right. I downloaded the assets.
Okay. So then from here, in this extracted folder, what you want to do is you want to first have Unity open.
Okay.
And you want to have this file explorer open as well, right?
Yep.
So then from here, what you want to do is you just want to click on this and then just select all the elements, including the meta files.
All
Yeah,
right.
and then drag and drop it to the bottom over here. I already did it, so I'm not going to do it, but you just want to drag it into this area.
All right.
Into the bottom.
Thank you.
Yep, no problem. Okay. So going back to the presentation, so we're going to take some various steps in order to create the platformer. So we're going to work on this step by step. So we'll go over the first step, which is actually creating the player character. To do this, we're going to be creating a game object and just calling it player, and then we're going to be assigning the game object components, which includes the sprite renderer, the rigid body 2D, and the box collider 2D. Let's do this first step first, right? Creating the game object. How do we do this? If I go back into Unity, I'm going to go to my hierarchy, because this is where you create your game objects. I'm going to right click and then go down to create empty. Okay, so click on this. And then from here, I'm going to call the game object player. So just type in player, click enter. There we go. We created the game object. So the game object is actually in our scene, but we can't see it yet because we haven't given it a sprite yet. So in order to give this a sprite, what we want to do is we want to assign it the sprite renderer component. So you want to click on add component, type in Sprite Renderer, click enter. And there you go. So we have the sprite renderer here. But as you can see, you still can't see the game object. Well, that's because we assigned it the sprite render component, but we haven't actually assigned it the sprite yet, the actual image to be used to represent the game object.
Sorry,
So,
sorry. Could you repeat that one more time?
Yeah, sure. So what we did is we added the sprite renderer component, right? And then, but the thing is like, since we added this component, we haven't actually assigned it a sprite yet. So we're gonna be doing that right now.
Could you show the add component part again?
Oh, the add component. Oh yeah, sure. So you click on add component, and then you just type in sprite renderer. So sprite renderer. Sorry, I typed it in wrong. And then you just click on this, and it should add it like this. Okay. Do you need any more clarification on anything, or are you good?
We're good. Thank you.
All right. So from here, now we've actually got to assign this a sprite. So we're going to go to the sprites folder over here in the assets. Double click on this. And then we're going to be clicking on this arrow over here to actually get all of our sprites, which I made for you guys beforehand. So what we want to do is we want to click on player, and then drag and drop the first sprite over here. So click on this and then drag it over here. Now we can actually see our player in the game. Okay. And if you go to the game view, we can see he's there, but he's pretty tiny right now, right? So we want to increase the size of the player so that we can actually see him properly.
Hold on, how did you get him in again? Did you like drag or something?
Yep, yeah, exactly. I just dragged and dropped. So I dragged and dropped this image in the sprite folder. I just dragged and dropped it to here, to where it says sprite.
Okay.
Yep.
All right.
So that, yep, no problem. So then what we need to do from here is we need to increase the size of the player character. How do we do this? We can see over here in this transform component that the player has some scale properties. So he has an X, Y, and a Z component. So we're going to change these numbers to, we're going to increase these numbers to increase the size of the player. So we're going to type in the X field over here, we're going to make this 3. And so that he's not squished, we're going to make it so that it's 3 as well. So the aspect ratio stays the same. So it's, we're just scaling it up by 3. That's all we're doing. And there we go. Now he's a lot more visible. You can scale this up more if you want, but I prefer to just use 3 and 3. I think that's good. Okay. So we added the sprite. Now we need to add 2 more things to the player character. So make sure you have player selected again. Go to add component, and then type in rigid body 2D, because we're going to be adding physics to the player because we're going to be using that. So type in rigid body 2D, and it should be the thing over here. So you click on this, and we've added physics to our player. In the rigid body 2D, we do need to change a couple of things. So the first thing we need to change is we need to make sure that the player doesn't have any gravity. We need to reduce the gravity to 0. The reason why is because like if you keep the gravity to 1, then the player will just like fall down the screen, and he won't land anywhere because there's no like platforms or anything. So we want to change this to 0 like for now, and we'll change it back later once we actually add platforms. So just go to gravity scale and change this to 0. Okay. And one other thing we need to do is we need to go to where constraints is, and click on freeze rotation, because we don't want the player to be rotating just randomly, because then that will lead to kind of like some very weird behavior. So we're just going to click on freeze rotation under constraints. Okay. So the last thing we need to add is the box collider. So to actually make the player character collide with things. So to do that, we're just going to go to add component again. We're going to type in box collider 2D. And we're going to enter this. I'm going to add that. Okay, and there's the box collider. As you can see, you can't edit it in here. So we have to go to the scene view. So just click on scene. And there we go. Now we can modify the box collider. So we need to click on this button first, actually, before we can modify it. So click on this, edit bounding volume, your edit colliders, and just resize it so that it fits the player character. So you can drag this, you can drag like each of the corners and resize it so that it's like pretty reasonable. So I think this looks pretty reasonable to me. Yeah, maybe you can move this a little bit. Yeah, so just resize the box collider so that it fits the player character. All right. And go in the game view. Yeah, there we go. We can see the collider there. Any questions on this part, or real okay? All right. I'm going to move on then. So right now, actually, I should probably show this. So if I run the game, you can see that nothing will really happen, right? Because the player doesn't move left or right. He doesn't do anything. All we did was literally just draw the player character to the screen. So now what we're going to focus on is we're going to focus on making it so that he can actually move left and right. How do we accomplish this? Well, we need to create a script in order to allow the player to move. And we're just going to be calling the script a player controller. Once we create the script, we need to initiate all the necessary variables, which I'll talk about in a bit. Then we also need to define movement logic and change the X velocity of the player depending on the key that is pressed. So first, let's actually create the script as the first step says. So we're going to go to the scripts folder, which I already created for you guys. So click on scripts. And then right click in this empty area. And then go to create. And go to create C# script. And then call this player controllers. So I recommend spelling player with a capital P, so player, and then controller with a capital C, controller. That's a good, because that's a good naming convention for scripts. You want to typically name scripts like this. So we created the script. Now we need to edit it. To edit the script, you can just double click here. And it should automatically open up Visual Studio. It'll take a little bit to get the script on here, but it should work. Yeah, there we go. So now we have our script.
Zahid, do we want to talk about the editor thing, setting the default editor?
Oh, yeah, sure. Okay, so if it doesn't open up Visual Studio for you guys, you want to go into edit, project settings, which, sorry, was it edit project settings or was it?
Preferences.
No, so, oh, I see, go to edit, preferences. And then you'll see here this window called external tools. You want to make sure your external script editor is set to Visual Studio Community on 2019, and whatever version you have installed. So if Visual Studio doesn't open, just do what I did, go to Edit, Preferences, and then just set it so that it's Visual Studio Community. Right. So now let's get into actually coding the player character. So first we want to make it so that the player character moves left and right, depending on the key that's pressed, right? So we're going to initiate a variable. Let's call this speed. So we're going to say float speed. Float just means a decimal number, by the way. We're going to set this equal to 5.0, and then we're going to write f afterwards. So that's how you define floats in C#. And as I mentioned, a float is just a decimal number. Okay, so we define the speed. There's one other thing. There's one other variable we need to define, which is the physics, the rigid body 2D, because we want to change the player's velocity, right? In order to change the velocity, we need to have access to their physics. So we're going to say rigid body 2D. And we're going to call this variable as well, rigid body 2D. Okay, and then we're going to put a semicolon after these variable declarations. Okay, so right now the rigid body 2D isn't set to anything. And so in order to actually set it to something, in order to actually get the physics of the player, we need to type in rigid body 2D dot get component, and then we're going to use these less than and greater than signs like this. Type in rigid body 2D here, open close brackets, semicolon. There we go. That's how you get the physics of the player. Okay. And as I mentioned before, we want to make it so that you change the x velocity of the player depending on the key that's pressed. Wait, sorry. Someone say something? Okay. We'll continue then. So we want to make it so that well, actually, sorry, first we'll focus on making it so that if the player presses the left key, they'll move left. How do we do this? Over here, I defined a, well, sorry, I didn't find a method, but Unity has a method called input.getKey, keycode.key. And this just simply returns true if the key is pressed and false if it isn't. So an example of this, if you say input.getKey, keycode.a, this returns true if the A key is pressed and false if it isn't pressed. So we'll be using this in order to detect if they're pressing the left key. So we're going to say if, we're going to define an if statement like this. So open close brackets, define the curly braces as well, like this, because C# is very similar to Java. So you have to define, you just have to write the if statements and stuff like this. So in the if statement, we're going to say if input.getKey, open close bracket, key code dot left arrow. So in this if statement, we're going to make the player move left, right? If they're pressing the left key, they move left. And to do this, we're going to change their velocity. So we're going to say rigid body 2D dot velocity equals. So what does a velocity equal? Well, if we highlight the velocity over here, this is a cool thing about Visual Studio. You can highlight things and it'll tell you what they are. We can see that the velocity is a vector 2. So we're going to set it to exactly that. So we're going to say is equal to new vector 2. Open close brackets, semicolon. In this, so the first component of the vector is going to be the x velocity. So we're going to set this to be negative speed because we want him to move left. So we're going to make the velocity negative, right? So negative speed, and this is the x velocity. The y velocity, because it could be jumping, we're just going to keep it the same. In order to keep it the same, we got to do this. We got to say rigid body 2D dot velocity dot y. All right. Any questions on this part or? All right, I'll move on then. So let's run this and let's actually make sure this works. So go back into Unity, click play. Oh wait, actually, sorry, this isn't gonna work. So if I press left, you'll see it won't work. That's because I forgot a very important thing. So make sure to stop the game. Make sure this button is gray. Go to player. Go down to add component, because what I did is I created a script, but I completely forgot to assign it to the player. That's why it's not working. So click on add component, type in player controller, click enter. There we go. Now we attach a script to the player. Okay, now this should work. So we click play. And he should move left when he presses the left key. Sorry, one other thing I forgot. I forgot to actually set the speed. Oh wait, no, I didn't. Okay, give me a second. Why didn't it work? I'll click play again. It should work. Try to get components, negative velocity. Why is it not working? Sorry about this. So I assigned it the player controller script. Object reference not set. Okay, yeah, that's weird. I don't know why it's not
If
working.
you go back to the script,
Yeah.
we're not setting rigid body 2D.
Oh yes, right. Oh my god. Thank you for pointing that out, Omar. I appreciate it. Sorry. So I gotta say rigid body 2D is equal to get component rigid body 2D. Thank you so much, Omar. Appreciate that. That was a simple mistake. I can't believe I forgot that. Okay, now this should end up working. Okay, we press left. There we go. He infinitely moves left, which isn't what we want. And I'll show you how to fix that in a little bit. But for now, we'll focus on getting the right input working. So if the player presses the left key, then move left. And we're going to say otherwise, if they press the right key, then they'll move right. So we're going to define this otherwise statement by saying else if input dot get key, key code dot right arrow. Right, and then we'll copy and paste this exact same thing, the rigid body 2D velocity, paste, and then just literally just remove the negative sign, right? Because you want him, in order to get him to move right, the velocity is going to be positive. To move left, it's going to be negative. All right, save this, and now we can run the game, and the player should be able to move left and right. Right, like this, but he still just keeps infinitely moving, right? Even though we're not pressing a key, he still keeps moving. So we need to define one other condition, saying that if they're not pressing the left and the right key. So we can say this by saying else, right? So if they're pressing the left key, move left. Otherwise, if they're pressing the right key, move right. In any other scenario, so if they don't press this and they don't press this, then we're going to set the velocity to be 0. So let's copy this, paste it here, and just say instead of speed, just put 0, and that should fix it. Okay, I'll go and play. And now the player should be able to move left and right properly. Yeah, let's see. There we go. Got him moving. And he stops when you let go of the input. Good. Any questions on this? Or can I move on? All right. Let's move on to the next step. Now, the next step is assigning the player idle and moving animations. So I already created these animations for you. So all we're literally just going to be doing is just assigning the player these animations. To do that, we're just going to click on player. Go to animations in that underneath assets. And then scroll down. Drag and drop this player thing over here. This is called the animator controller. Drag and drop that to add component. Let go, and we added the animator controller to our player. And the last thing we need to do is we need to drag and drop the script, the player animation script, which I created. So if you go to scripts, the scripts folder, drag and drop player animation, which is should be the first thing that's here. So just drag and drop this, and also drag and drop that to add component. And we should be able to give our player animations this way. So if I click play. There we go. The player has idle and moving animations. Right. So now we can move on. So yeah, this is just some logic that I used for the animations. Unfortunately, I can't really go too in depth in this because actually making these animations took quite a while. But I did link some videos that you guys can refer to if you're interested in creating your own animations. So you can check those out if you're interested. So now let's move on to actually making platforms for the game. To do this, what we're going to be doing is we're just going to be creating a tile map. We're going to be creating a tile palette, and then we're going to be creating a tile that represents a platform. And then we're also just going to be adding colliders to the tiles. All right, so this part involves no coding, so it should be pretty straightforward. So in the hierarchy, what you want to do is you want to right click, go to 2D object, tile map, and then go to rectangular. Because the platforms in this game are going to be rectangular platforms. They're not going to be like circles. They're not going to be anything else. Okay. So then you have this tile map added here. And then another thing we got to do is go to assets, right click, go to create, and go to folder. Because what we want to do is we want to create the tile palette and the tiles, and we're going to store those two in the tiles folder. Okay, so once you create that folder, go to the scene view, click on tile map. And you can see over here, creating a tile palette is very simple. All you have to do is just click on this button where it says, sorry, remove that button now, but yeah, you just want to click on this purple button and you'll be able to open up the tile palette. So in order to create the palette, as Unity says, you create a new palette in the dropdown above. So we're going to click on this dropdown. We're going to name this tile palette. Let's call this platform palette. You can call it whatever you want, but I'll just call it this. Go to create. And then we're going to save this in our newly created tiles folder. So just click on tiles, click select folder. And there we go. We saved the tile palette to the tiles folder. Now we actually have to add tiles to this tile palette. If you're sort of confused about what tile maps, tile palettes, and tiles mean, so you can kind of think of the tile map as like the canvas of our game, right? And in order to use a canvas, we need to have a paint palette, right? We need to have like paints to select from. That's what the paint palette's for. So exact same logic with the tile palette. The tile palette has all the tiles that we can select from to paint our canvas, which is the tile map. So in order to create a tile, what we're going to be doing is we're going to be going to Sprites. And you see I already have a platform sprite over here. So click on this arrow, drag this image to the platform palette. Okay, now it's asking us to save this platform. So to keep things organized, let's save it to the tiles folder. So let's go to assets, go to tiles, and then save here. And there we go. We have the tile in our tile palette, and we can start painting our level with platforms. So in order to paint the level, select the tile and click on this paintbrush tool over here, paint with active brush. And now, as long as you're in the scene view, you can drag and drop the tiles and you can create platforms like this. So you can see it's super easy to create platforms using this method. So you can just do whatever you want. I'm going to make a platform like this. I'm going to maybe add some walls over here, fill in a couple gaps. But yeah, you can design the level however you want. So that's a really cool thing about Unity. And if you want to remove some of the tiles, you just click on this eraser button, erase with active brush, and then you just drag and you can delete any tiles that you click and drag on. So I'm just going to paint them back, but yeah, that's pretty much the gist of the tile palette, and it's a really useful feature. So now what we're going to be doing is we're going to go back into player, because now there's platforms, right? And the players should be able to walk on them. So we're going to give the player his gravity back. So we're going to set this gravity. Maybe we can set it to like 7, worked pretty well for me. So just go back to player, go to where the Razor Body 2D is, and set the gravity scale to 7. All right, so I'll save that. And let's run the game. And this shouldn't work because the player, yeah, see, he just falls through the platforms. That's because we created the tiles, but we haven't added a collision to them yet, right? We need to add a collider 2D. Just like we did with the player. So to do that, click on tile map, go to add component down here, and then type in tile map collider 2D. So tile map collider 2D. Yeah, so it should be the first thing that's here. Enter. There we go. We have collisions on our tiles now. It says easy as that, or well, so it seems. Let me run the game, and our players should be able to walk on these platforms now. But there are some issues. So you can see, okay, I moved left and right, but the player gets caught in between one of the tiles. This is because there's a lot of unnecessary collisions inside of these tiles, right? Because the collisions inside of the tiles, they can cause like some weird behavior like this, because the player can't move at all. So we want to be able to remove the collisions inside the tiles and fine tune them properly. How do we do this? Let me stop the game. All we need to do is we need to go to add component, type in composite collider 2D, and it should be the first thing that pops up. And from here, what we want to do is we see that when we added the composite collider 2D, it automatically adds a rigid body 2D. To be honest, I'm not sure why it does this, but all we need to modify for this rigid body 2D, we just need to make it static because we don't want the platforms to be falling or anything like that. You could make them do that if you want your game to be like that, but for this game, we just want the platforms to be stationary. So we're going to set the rigid body 2D to be static, so they're not going to move at all. And then the last thing we need to do, because you can see the collisions haven't changed, we're going to want to go back to where the tile map collider 2D is. And then we're going to click on used by composite. And there we go. Now the collisions on the tiles have been fixed. There's no collisions inside. And the only collisions that are there are on the outside of the tiles. And you can see that the collisions even apply with any new tiles that you draw. So if I were to paint like some new tiles underneath here, you can see that it just automatically creates collisions for you, which is like a really helpful feature. And that's why the collider is, that's why using tile maps just in general are just so useful. Okay, I'll delete these platforms. Just want to show you guys what this does. So let me exit out of here. Let me go to play. And now our player should be able to walk left and right on the platforms with no issues. He doesn't just unnecessarily stop like he did before, because the collisions are a lot more simpler now. Okay. Any questions on this part? Okay. Let me move on to the final step, which is getting the player to jump. Because right now he just moves left and right, but we're interested to make him jump, right? Because this is a platformer and the player should be able to do that. So what we need to do is we need to initialize the variables in the player controller script. We need to make the player jump if the spacebar is pressed. And then we also need to detect if the player is on the ground and be able to use it in the player jump. So let's do this first step first, which is initializing the variables. So let's go back to the player controller script. So if I go to scripts, double click on player controller, or if you already have it open, you can open Visual Studio, it doesn't matter. Yeah, I think it didn't, yeah, there. Okay. So we need to make it so that, we need to initialize the variables. So what's the variable we need for jump? Well, we need to figure out the jump speed, right? So we need to define a float, call this float jump speed. And we're going to set this to be, let's set it to 20. I think 20 worked pretty well good for me. So 20.0 F, semicolon, there you go. So we set the jump speed. And similar to how we changed the X velocity to get the player to move left and right, we need to change the Y velocity to get him to move upwards, to get him to jump. So we're going to say, after all this, we're going to say if input.getKey, and we're going to make him jump with the space bar. So we're going to say key code dot space, and then put the curly brackets like this. And now we just need to change the Y velocity. So we're going to say rigid body 2D dot velocity equals new vector 2. So we're going to keep the X velocity the same, right? Because we don't want to change that because that's already being changed here. So rigid body 2D dot velocity dot X. And then we're going to change the Y velocity so it adds jump speed, which sets to 20 there. Okay, so if we run the game, we know that this won't work because we don't detect it to players on the ground. But it will still make the player jump. But it just not what we want him to. So we press the spacebar, okay, he jumps. We press and hold it, he just goes out of the screen, which is not what we want. And that's why we need to check if they're on the ground so that he can only jump if he's on the ground, right? Okay, so I'm going to stop playing this. Let's try to figure out how do we do this? How do we detect if the player is on the ground? So what we're going to do is this. So the player is over here, right? The platform is over here. what we need to do is we need to create some sort of detection box that can detect that follows the player around, that detects if they're on a platform. So how do we actually create this detection box? We can use this function over here, Physics2d Overlap Box. You can see it takes in a bunch of arguments. So it takes in a point, the place where you want to put the box. It takes in the size, how big do you want the box, angle, do you want the box at an angle or not? Well, obviously we'll set this to 0 because we want it to be a box, not like a diamond or anything. And then it also takes in one other argument, which sounds kind of confusing, a layer mask. So what is a layer mask? Let me show you right here. So if I go into Unity, if I click on literally just any game object over here, so I'll click on tile map. You can see over here that at the very top, there's something called a layer. That's the layer mask that we're talking about. You can see over here in the dropdown, we can change the layer to be whatever we want. So the idea is to create a new layer called the platform, assign the tile map to that platform layer, and then detect if the player is on the platform layer. So we're going to click on add layer. Let's go to user layer 6 and then type in platform. Okay, save this, click out, and now it should have added our layer. If you go back to the dropdown, there we go. The platform layer is there. We're going to click on that. Okay, so now we added the platform layer. Now we need to actually create this box that I mentioned before. To do this, let's go back into the player controller script. And let's create a function that returns true if the box overlaps the platform, and returns false if it doesn't overlap the platform. So we'll define the function by saying bool is grounded. So that's what we're going to call the function. We're going to call the function is grounded. We need to do the curly braces like this. And now let's use this Physics2d Overlap Box. So I'm going to type in Physics2d Overlap Box. And if I highlight this, you can see that it's a Collider 2D. So we're going to store this in a Collider 2D object. So we're going to say Collider 2D. We're just going to call this ground collider is equal to Physics2d Overlap Box. All right. So now we need to specify the point at where the box is, and we need to specify the size. So the point will be the player's position. So we can access the player's position by typing in rigidbody2d.position. We're going to specify the size of the box. So if we highlight this, we can see that the size is a vector 2. So the x component of the vector would just be like the width. The y component would be the height of the box. So I'm going to say new vector 2. Close bracket. And then we're going to say the box is going to be, I think, 0.5 work pretty well. So we're going to say 0.5, 0.5. And then we need to specify the angle. So comma 0.0f. That's what the angle is going to be. Does anyone need me to go over this again? Because it's this is a pretty long line of code. So. Okay, doesn't look like it. Okay. So there is one argument we forgot to define, which is the layer mask. So let's define the layer mask over here. We're going to say layer mask, platform layer mask. And then in front of this, we need to add something. This is going to be a big confusing. We need to add something called serialized field. What serialized field does is it allows us to view this this variable in the inspector window. So if we add this variable, save it. Let's go back to player. Scroll down. And in the player controller script, it should add. Okay, I don't know why I didn't add it. Oh, sorry, I think I saw something there. Player controller is grounded. Oh, okay, no, I see why. I forgot to do this. I forgot to return a value here because the code is not compiling because I haven't returned a Boolean. So let me, so after this collider, because you just want to, this works. So we're going to say return ground collider is not equal to null. And now it should, the platform layer mask should appear now that we're returning a Boolean. Okay. So now go back to Unity, go to player, scroll down, and there we go. Now the platform layer mask appears. And then we'll just assign this because it's a dropdown. We'll just click on this and we'll assign it to the new platform layer that we just created. So click on this. Click on platform. Okay. Now we'll go back to the code. And let's test out this function. Let's go to debug.log. So in the update function, just type in debug.log because you want to just check if the player is grounded, right? We don't want to add it to our stuff yet. We want to just make sure this function actually works. So we're going to do that by saying debug.log is grounded. All right. If we run the game, and we go to console, because debug.log prints to the console, you can see that it's just constantly returning true, which is interesting. Even if we go away from the platform, it doesn't return false, right? Because if they're in the air, this should return false. If they're on the ground, it should return true. But it's not working like we want it to. So in order to figure out the problem, oh, yeah, okay, no, sorry. The problem was that I forgot to add the extra argument. Sorry about that. So you have to add a comma after this, and then type in just platform layer mask. Yeah, I'm sorry about messing up like this, but yeah. So just add that. Click save, and then run. It should, because it should just constantly return false. Click play. Yeah, there you go. Now it's just always returning false. Even if we're on the ground, it's returning false. So what we need to do is we need to figure out why it's returning false. Because we created this box in space, but we can't actually see where the box is. In order to actually see this box, and in order to properly like modify it and whatnot, properly modify and stuff, we're going to be using this thing called Gizmos.drawWireCube. And this just draws a cube at a point when the Gizmos thing is selected. So you can see over here, there's like a Gizmos button over here. So when you select that, you can be able to, view this box that we'll be creating. So this box only works in this onDrawGizmos function. So let's create that function. So after the is grounded, we're going to say void onDrawGizmos. And then we're going to type in gizmos.drawWireCube, open close bracket. And then from here, it creates a cube at the point of size. So we're literally just going to copy the first two things over here because this is the point and size of the Physics2d. So we're just going to want to be able to view this in the game. So just copy and paste that, paste it there, and we will run this and we'll see where the box is. Click play. And we see the box is drawn in the center of the player, which is not where we want it, right? We want it to be like at their feet pretty much. It's good that we did this. So we know that the issue was where the box was positioned. So what we want to do is we want to move this box down. In order to do that, we're just going to add, so we're going to say plus vector 2 dot down. And we're going to multiply this by like 0.6f. You might have to multiply it by a different value depending on how you made your box colliders and whatnot. But I think 0.6f should just in general work. So I'll copy this and I'll paste it in the wire cube as well because you want to see where this box gets drawn. You want it to match up. Click play. And there we go. So you can see over here that is grounded returns true. If we're off the ground, it starts returning false. Go back on the ground, it returns true. So this looks like it works. Okay. Now we just finally, we just need to add this is grounded function into this if statement over here, because now that we know it works, we can use it. So let's remove the debug.log and let's say is grounded. So if the player presses the space bar and they're grounded, then they'll be able to jump. So now I'll go to play. And if I just spam spacebar, I can only jump when I'm on the ground. And yep, that's how a jump works in video games. Do you guys have any questions about this, or do you want me to go back to the code? I can do that as well. Okay. So a final thing we can do is, because as I mentioned before, we want to have the physics stuff in the fixed update function. So we want to move the physics calculations from the update to the fixed update function. To do this, let's scroll upwards. And let's create a function. We'll just define it after start. We'll say void fixed update. So you have to manually define the fixed update function because Unity doesn't give that to you by default. So let's copy and paste all this code. We'll cut and paste and we'll put it in fixed update. But it's not going to be that simple. The reason why I do this is because, like, well, there's the physics calculations here, right? But this won't work properly because if I click play, you can see like there's some like kind of weird delays with both like the animation. Like it works like decently well, but there's still a little bit of like delay compared to when we had it in the update. So what we need to do is we need to, the reason why there might be, there's some delay is because we're getting the input from the player every 0.02 seconds. But of course, you want to get input from the player like a bit more like frequently than that, right? You want to get the input from the player every frame instead of every 0.02 seconds. So to do this, what we're going to be doing is we're going to be creating variables that keep track of the input values. So we're going to say bool left input, and then we're going to say bool right input, and we're also going to define bool jump input. So we have these three booleans. So what we're going to do is we're going to be setting the values of these booleans in the update function. So we're going to be getting the input from the player in the update, and then feeding the Booleans back to the fixed update. So to do this, we're going to say left input is equal to the left arrow key. So just copy this, paste it here. I'm going to say the right input is equal to the right arrow key. So input key code right arrow. And then we're going to do the same thing with the jump input. So jump input is equal to input.getKey key code dot space. All right. So now we have these Booleans that's for the input. So all we've got to do is just replace these with just left input. Got to replace this with the right input. And then just finally replace this with jump input. And there we go. Now this shouldn't be any delays or anything when the player moves, because we're getting the inputs every frame instead of every 0.02 seconds. Yep, there you go. It was fine now. All right. So yeah, so that's all I want to talk about today. So as for next steps in the game, you can make a camera, follow the player, and I would highly recommend looking into Cinemachine in order to do that. It's a very simple library that you can download into Unity. So I recommend looking into that if you want to make a camera, follow them. I would also consider adding an objective to the game, because you want to figure out how the player will win the game, right? Because sure, we created a platformer, but how will they win in this platformer? Another thing to consider is replacing the sprites with either your own or some others that you may have found online. I have some resources for that I can share with you in a bit. You also might want to consider adding some more animations. You can consider adding a jump, fall animation, just any animation you want. You can add some combat as well, add enemies, and a lot. And there's a lot more you can do with this game. And if you want to see the final project, if you want to be able to download this, you can access it through this GitHub link over here. You should be able to download it and open it up in Unity. I actually did include a camera in this project as well. So if you want to see how Cinemachine works, you can download it over here. And here are some resources that I use. So for the jumping code, I watched this YouTube video in order to get like the code for this jumping. But there's a lot of different ways to actually make the player jump. I just showed you one of the possible ways to do that. As for the assets used, I got them from the asset store, where you can access over here in this link. And as for fixed update versus updates, I highly recommend checking out this video if you want to see a more in-depth explanation of why you use fixed update over update for physics calculations. Here are some resources from Sprites. You can use this tool to create sprites and animations. And then here's this. There's this website called Sprites Resource, where you can find a lot of sprites from existing video games like Mario, Sonic, whatever game. You can access all these sprites through this website. You can also use the Unity Asset Store, and even Pinterest has some cool sprites. And then here's some useful links if you want to learn more about Unity. So Unity has their own education, has their own like kind of education system. So you can use Unity Learn, where they offer lessons in both video and text format. You can click on that if you're interested. I also highly recommend checking out Brackeys, which is a very popular within the Unity community. He has a lot of tutorials on how to do different things in Unity, like for example, how to add combat to your game, how to add animations, etc. Blackthorn Prod is also pretty good. Here's the link to Unity documentation. I also recommend checking out the Ruby tutorial. where I learned like how to I learned like quite a bit from doing this tutorial. It's a little bit outdated, but you can still like learn quite a few things from it. If you want to know how to use animations, you can just check out this tutorial, and there's a lot more resources that you can use. Okay, and that's the workshop. So yeah, so thank you guys so much for coming. Really appreciate it, and I hope you learned something from this. If you have any questions, you can either like message me, or you can even message Bilal, although Bilal could probably help you more with like AR, VR stuff. I could try to help you more with the platformer things. So